Hello, today we're going to be solving quadratic equations by factoring. So we're going to factor some quadratic equations and we're going to solve them. So basically what we're looking for are two x-intercepts or roots, and we're going to graph them as well today. So if you've seen the video before, factoring trinomials, both simple and complex, it might help with your PYQ skills in terms of solving quadratic equations by factoring. Here's factored form, and within what we're doing, this is what we're looking for when we're graphing parabolas or quadratic equations, with that as well. So we need two factors that add to a positive 9 and that multiply to a positive 18. So we need our brackets equals 0. We need x and x to multiply to positive x squared plus 6 plus 3. Then we have set equal to 0 and then solve. And here are our two x-intercepts. And here is our therefore statement. So x equals negative 6 and x equals negative 3. So we had our quadratic equation equal to 0. We factored it, and then we set them equal to 0 to find the roots. Zeros are x-intercepts. And we set it equal to 0, and then we solved for x. Moving on. So we need, it adds to negative 1, and it multiplies to negative 12. So we have our two brackets equals to 0. We have x and x. So we need to multiply x and x to get x to the power of 2. So we have plus 4, actually no. We have minus 4 plus 3. And then we have x minus, so we set them equal to 0. And then we solve for x. X equals 4, and then x equals negative 3. So we had our quadratic equation. We factored our quadratic equation, or our trinomial. And then we set the pieces equal to 0. And then we have our isolated x-intercepts. So we have what x equals for both. And then we need to graph it as well. So 4 and negative 3. Again, a negative 12 is the y-intercept, but we'll just graph that for now. Okay, so we need two factors that add to positive 1 and multiply to negative 42. So we get our brackets ready, equals to 0. We need x and x to multiply to x to the power of 2. And then we need plus 7 and minus 6. And then we have, we take those, we factored it, and now we need to take those pieces, we need to set them equal to 0 to find the x-intercepts. x minus 6 equals 0, x equals negative 7, and then x equals 6. Okay. There you go. So we have negative 7, and then 6. We have x-intercept here, negative 7, comma 0. And we have x-intercept here, 6, comma 0. And then that's our answer for those two. Okay, so we need two numbers that add to negative 10 and multiply to positive 16. And we are gonna do our brackets equals 0. We need a and a. And then we need two numbers that add to negative 10 but multiply to negative 16. So I'm thinking negative 8 and negative 2. And then we set the pieces equal to 0. Then we have a equals to 8 and a equals to 2. And then that would be our therefore statement. So we have 2 and 8. And that's our x-intercept 2, comma 0, x-intercept 8, comma 0. And there you go. So as you can see, we have these two would add up to negative 10 and then multiply to positive 16. Alright, so we needs to add to positive 4 and multiply to negative 45. Alright, sounds good. So we need our brackets equals 0. We have y and y. And we have plus 9 minus 5. And then we have y plus 9 equals 0. Then we have y minus 5 equals 0. Then we have y equals negative 9. And then y equals 5. And that's our solved quadratic equation. So we have our quadratic equation, we factored it, then we set each piece equal to 0, and then we found the x-intercept values. So we need negative 9, and then we need 5. So this would be x-intercept 5, comma 0. And this would be x-intercept negative 9, comma 0. Moving on. So we need two numbers that add to negative 3 and multiply to negative 40. So we get our bracketed expression equal to 0. We need n and n. And now we need two numbers that can add to negative 3 but multiply to negative 40. So I think negative 8 and positive 5. And then we need to set each piece of the equation equal to 0. And then we need to solve for it. N equals negative 5. And that is our answer. So we have 8, negative 5, x-intercept and that is our x-intercepts there as well. Moving on. So we have w's, and we need two factors that add to negative 16 but multiply to positive 63. So we have w and w, and then we have negative 9 and negative 7, I believe. And then we have w minus 9 equals, and then we set each piece equal to 0. And we have w equals 9 and w equals 7. And that would be our answer, w equals 9 and w equals 7. And then we have 9 here and 7 here. And then we have our x-intercepts. X-intercept would be 7, 0. X-intercept would be 9, 0. So yeah, that is G. And then we have H. We need two numbers that add to negative 2 and add to and then add to positive 1. So we need to get our brackets ready. Equals to 0. We have D and D. And then we have negative 1 and negative 1 as well. So for this one, we have D minus 1 equals 0. D minus 1 equals 0. And then we have D equals 1 and D equals 1. And that is our answer. And then we have the 1 right here, and it's gonna bounce off the x-axis. Because it is a order of 2. A factor appears twice. The x-intercept labeled there. Alright, moving on. We need two factors that add to 11 and add to multiply to positive 30. So we need our brackets ready here. Equals 0. We have h and h. And then we need plus 5 and plus 6. So they add to positive 11, and then they multiply to positive 30. So we have h plus 5 equals 0, setting the pieces equal to 0 again to find the x-intercepts. And then we have negative 5, and then h would be negative 6. And then we need negative 6, negative 5, and we have x-intercept negative 5, 0. X-intercept negative 6, 0 as well. So, we are solving. So all of the questions so far have been simple trinomials, but now we're gonna go and dive into complex trinomials. I've done a video on that as well, if you'd like to go watch that for previous knowledge in regarding this course. And let's begin. So we have 2a to the power of 2 minus 3a minus 2. So we need two factors that multiply to 2a2 and two factors that multiply to -2, and they must match in the middle. They must match the middle term and see if they match anyways. So we need our brackets. We have 2a and a, and -2 and +1. So when we so this would be like foiled out. So 2a minus a multiplied by a would be 2a squared minus 4a plus 1a minus 2. Then it's 2a squared minus 3a minus 2, and that is the original expression. There you go. And then, so we have the original quadratic equation. We've factored it, and then now we need to set each piece equal to 0. So a plus 1 equals 0, a minus 2 equals 0. Then we have 2a equals -1 over 2 over 2. And then we have a over here equals 2. And then we cross out, and a would be -1 over 2. So we have those. So we have both of the x-intercepts. So we're going to do -1/2, and then +2. Alright, so this would be x-intercept 2, 0, and then that would be x-intercept -1 over 2, 0. Moving on. So now we have 3a to the power of 2 plus 10a minus 8. And we need two factors that multiply to 3a to the power of 2, two factors that multiply to -8, and the middle term must match. So we have, get our brackets ready, equals 0. We have 3a and a, which are 3 is a prime number. So it's just 3a, it's just 3 and 1 that would get you to 3. And now we need, we'll do +4 and -2. And that is our, and then we'll move on to setting each piece equal to 0. And then we have, so 3a equals 2 over 3 over 3, crossing out 3's, and 3, 3. So a would be 2 over 3, and then we have a equals -4. So a equals -4, bring it down. And then there you go. So we have 2 over 3. And -4. So we have both x-intercepts labeled. We have 2 over 3, 0, and then we have -4, 0 as well. And now moving on, we will have, again, we need two numbers that multiply to 2n to the power of 2. Then we need two numbers that multiply to +2, and then we need them to match in the middle, with the middle term +5. we have 2n, then just n, and then we have plus 2 plus 1. So we have 2n squared, then plus 4n plus 5n plus 2. So that being said, 2n plus 1 equals 0, and then n plus 2 equals 0 as well. And then we have n equals negative 2, and then 2n equals negative 1 over 2 over 2. And then we have n equals negative 1 over 2, negative 1 over 2, and then n equals negative 2. And that is our, so we have a negative half, and then we have negative 2. And then we're going to so that would be negative half 0, that's x-intercept, and then we have negative 2, 0, that's an x-intercept as well. Moving on, we have d. So with d, it is going to be quite simple. We need 2z plus 1, so that's going to be 4z squared. Then plus 2z again equals plus 4z, and then plus 1 is at the end. So we have 2z plus 1 equals 0, 2z plus 1 equals 0, and then we have 2z equals negative 1 over 2 over 2, strike out common 2's, and then z equals negative 1 over 2. Then we have 2z, negative 1 over 2 over 2, strike out common 2's, and we have z equals negative 1 over 2. And then we have, so it's order of 2, bounces off x-axis, and then it is negative half, and then we have up and up. X-intercept would be negative half, comma 0, and that is our x-intercept. There you go. And now we have E. So we have our brackets equals 0. We have 3a, and then just a. And we have minus 1 plus 1. So we have 3a to the power of 2 plus 3a minus 1a would be plus 2a. And then minus 1a plus 1a multiplied together would be negative 1. Sorry, if we were to expand this out, it would be 3a to the power of 2. Then it would be 3a minus 1a plus 2a. And then minus 1 plus 1 would be negative 1. And then we have 3a minus 1 equals 0. A plus 1 equals 0. A equals negative 1. 3a equals 1. 3 over 3. A equals 1 over 3. And then we bring this down. A equals negative 1. Okay, so we have 1 over 3 and negative 1. 1 over 3 and negative 1. So our x-intercept is 1 over 3, comma 0. And then our x-intercept is negative 1, comma 0. And that is our x-intercepts. And that is all I have for you today. I hope you found that extremely helpful, and thank you very much for listening.